Hey guys, let's start off today by going over the homework from last night, the insolation homework. So I will start here and let's just see what we had to do. Number one, the coldest climates on Earth are located at the poles, primarily because the polar regions, you should have gotten choice A, receive mostly low angle insolation. Remember, those are called tangential rays at the poles. Basically, the lower the angle of insolation, the less heat. Number two, compared to polar areas, why are equatorial? You can see the word equator in here. Areas of equal size heated much more intensely by the sun. And I don't know if you remember the word perpendicular, but perpendicular means that the sun is directly overhead, forming a 90-degree angle with the horizon. So choice A for number two, the sun's rays are more nearly perpendicular at the equator than at the poles. For number three, they just want to know which surface is receiving the greatest amount of energy where the sunbeam strikes the surface. So you got to look at the angle of insolation. And if you look at the angle of insolation, you will see that the highest angle of insolation, the one that's most nearly directly overhead, is choice B. See how, like, if a person is standing down here, the sunbeam is almost at a 90-degree angle. If they asked you which one is getting the least amount of energy, you would answer D, because you could see it's the lowest angle of insolation. For number four, on which date does maximum insolation usually occur? Well, remember, the more insolation, the hotter it is. And they ask about New Jersey. Now, I don't care if they ask about New Jersey, New York, California, Michigan, Maine, wherever it is. If it's in the United States, we are in the northern hemisphere, and maximum insolation would be the strongest rays of the sun. That would be in the summer, the first day of the summer. So that would be June 21st. 4 is A. For number five, which graph best represents the relationship between the angle of insolation and the intensity? Remember what we said. The higher the angle of insolation, the greater the angle of insolation, the more intense. Up and up, that's a direct relationship. You should have gotten choice B for number five. Let's go to the second page. And for number six, they give you this sphere and they tell you that this is the paths of the sun as viewed by this observer. This person's located at 50 degrees north latitude. So they're a little bit north of us. We're at about 42 degrees north. And they tell you this is June 21st, the path of the sun, and that is March 21st. Which statement best compares the intensity and angle of insolation at noon? And they even mark it for you. Here's noon here, whoops, and here's noon on June 21st. And if you take a look, on June 21st, the angle of insolation is greater. Therefore, you'll have a greater angle of insolation on June 21st, and the higher the angle, the more intense. So for number, what are we on here? Number six, you should have gotten B. The intensity and angle insolation are greatest on June 21st. If they asked which was the least, there would be another path here. December would be the least intense. And for number seven, the diagram below shows Earth as viewed from space on December 21st. The longest duration of insolation will occur on December 21st. Well, notice what they did here. They shaded half of Earth, and that would be the side that is facing away from the sun. Remember, Earth rotates on its axis, and if you take a good look, 90 degrees south on December 21st, you can see the southern hemisphere is tilting to the sun. It's their summer. So the longest duration of insolation will be somewhere south of the equator. And in fact, if you just imagine this, this is going to keep rotating, and 90 degrees south will never rotate into darkness. They'll actually have 24 hours of daylight on December 21st. So you should have gotten choice D for number seven. And one last question. right here. And they give you these rays of the sun striking Earth's surface at 23.5 degrees north latitude at 3 different times of the year, A, B, and C. Notice at A, the sun is directly overhead. So if you are at 23.5 degrees north, you're in the northern hemisphere, and the only day of the year where 23.5 degrees north has the sun directly overhead, well, that would be summer. So this has to be June right here, and they want to know the sequence from A to B to C. So A would have June, and then look at the lowest angle is at C. That would be December. And in the middle, June, September, December. There are 2 choices that show that. But then they want to know about the intensity of insolation, and this would be the most intense when the sun is directly overhead. Then you get here, you're getting, see how the light is starting to spread out, less intense, and this is least intense. So as you go from A to C, you have decreasing intensity. Okay, that covers that. Now, let's go to today's work that we are doing. And if you take a look here, we're going to look at shadows today. I don't know if you can hear, my son is screaming in the background. He doesn't want to go to bed. But anyhow, shadows. Here we go. Take a look. Since we're covering insolation, the intensity of the sun, what we have to do is figure out when do we have the longest shadows, when do we have the shortest shadows. So take a look. Here is the sun rising, right? You can see the arrow, the sun's going up. Now it's at its high point, that would be noon. And now it's starting to set at C. And they show the corresponding shadows of this stick. Notice, at A, you get a decent sized shadow. B is the shortest shadow. And C is the longest shadow. So the higher the sun is in the sky, the shorter the shadow. And the highest the sun is in the sky during the day is at noon. So you're going to get a short shadow at noon. And the longest shadows during the day will be when the sun is lowest in the sky. That would either be, they don't show it here, when the sun is first rising or the sun is setting. Okay, so that is how we tell shadows. There you go. So if the sun is located directly above the object, there is no shadow. Take a look at this picture here. See how the light is shining right down on this person? You can see there's really no shadow. It's right underneath them. Then as the light goes a little bit lower in the sky, notice what happens to the shadow. It gets longer. So the longest shadows during the day would be 2 times a day, sunrise and sunset, because the sun is lower in the sky, and the shortest shadows are at noon, because the sun is highest in the sky. Now, if they asked you what time of year you get the longest and shortest shadows, well, think about it. The shortest shadow during the year would be when the sun is highest in the sky. Here in New York, the sun is highest in the sky. We get the greatest intensity of insolation on June 21st. So we actually have shorter shadows in the summer, and the longest shadow would occur when the sun is lowest in the sky. That would be December 21st. One other thing to note. If they were to ask you something like, let's say, they give you directions. And all right, this is noon, right? And just know that the sun in New York in our sky is always south of us at noon. Always south at noon. A way to remember that is sun starts with S for south at noon. So south at noon, but it says sun, not sand, but whatever. All right. Then let's just say that, all right, the sun is setting here. So this would be the sun sets in the west. All right, so if they were to ever give you a picture, you see this long, long shadow, the shadow here, and you see the sun setting, this would be the east. So if you see a shadow in the east, a really long shadow in the east, that tells you that the sun is setting in the west. And they could do it vice versa. They could have the shadow in the west, and this would be sunrise in the east. All right, so you just kind of got to put the pieces there together. That's how we do shadows. So what time of day would shadow A form here? Well, this is exactly what I was talking about. Take a look. What time of day would shadow A form? Well, it looks like it's a short shadow going to the north. And remember what I said, always at noon, the sun is highest in the sky and to our south. So that's how you would know that. All right, and then what time of day would shadow B form? Take a look. Here you go. Long, long shadow in the west. That means the sun is down here. It's first rising. The sun rises in the east. So this would be maybe like 7 a.m., or you could just say sunrise. And the reason you know it, the shadow's in the west, so the sun must be rising in the east. That's shadows. Now let's just take a look how the temperature changes over the course of a day and a year on Earth. And here's how we know this. We've kind of done this already, right? We talked about this picture. The sun's energy is going down, hitting Earth. Earth is a dark surface, so it absorbs the sun's rays. These rays are the ones that are coming down. Those are called UV rays coming down. Then, after it gets absorbed, a good absorber is a good radiator, right? So first we see the light in the visible light, and then later in the day, these rays get released as longer wavelengths, and they return to space. This is infrared. All right, so here's the thing. What is happening to all of the energy from the sun? Well, you can see here in the atmosphere, you see these little particles. This could be dust, it could be pollution, it could be clouds, and a good portion of it will get absorbed, scattered, or reflected by the clouds as well. If you get a question like that on one of the worksheets, it's going to give you numbers. It'll probably give you a picture and a graph. Okay, next up is, you see 25%. Clouds reflect about 25% of the sun's energy on a typical day. Next, aerosols. What are aerosols? Aerosols are those things like if you use spray cans or something, deodorant, air freshener, you could see like a little mist come out of the can. Those are aerosols, and those little particles go in the air. Those would be pollutants. We also have natural aerosols like volcanic ash that comes from volcanoes and dust from the ground. And when those aerosols get in the air, they block the sun's energy from hitting Earth. So if we increase the aerosols, then you have a layer in our atmosphere that will block the sun's energy from hitting Earth, and that would decrease insolation. That is why a cloudy day is a cooler day. All right, so let's just a couple other notes here. Snow and ice. Snow and ice, they are light color, smooth, and we said smooth and a light color are good reflectors. In fact, know this, snow and ice are the best reflectors of the sun's light. The best absorber would be like a forest because it's dark and rough. And we did this already. I know we did this. I just explained it to you, but just to explain it again, here's the reference table. Here's the story of the sun. And A, you got those short wavelengths coming down. Those are UV rays, insolation, that's incoming energy. And the ground absorbs that energy, re-radiates it. This is actually infrared, the longer wavelength. There's another name for it, also called terrestrial radiation, in case you see that. And just remember that this tells the story here, right? Start at the left, we get UV rays coming down from the sun. Right before they hit Earth, we're able to see it in the visible light. And then after the ground absorbs and re-radiates that terrestrial radiation going back to space? Infrared. So you could see this area here in the reference table tells the story. And how much energy enters the atmosphere and how much leaves will determine the overall climate, how hot it is or how cold it is. So if you have more UV rays coming down than energy going back to space, that would mean more heat. More heat would mean a warmer climate. And if you have more energy escaping than coming in, that would mean a colder climate. And one last thing is something called radiative balance. Radiation coming from the sun and how it's balanced. Now here's the thing, we just talked about gaining energy versus losing energy. And the key thing to know is this. If you have radiative balance, the amount of incoming energy from the sun would be equal to the amount escaping our atmosphere. But that doesn't happen on a daily basis. Every day is a different temperature. It doesn't happen on a weekly basis. That changes too. Doesn't happen on a monthly basis or even a yearly basis. Some years are warmer than others. But if you were to average it out over a 10-year period, we're usually in radiative balance, but that is changing with climate change. We'll get to that later on. And why don't we throw this up here? I think you know what movie that is. So what's greater here, insolation or terrestrial radiation? Well, if we have more insolation, it would be hot. If we have more terrestrial radiation, radiation escaping back to space, it'll be cold. This looks like an ice age, doesn't it? So therefore, terrestrial radiation will be greater than insolation here. And then look here, you can see that's a desert. That's very hot. That would be greater insolation than terrestrial radiation. In fact, that's just the story of our planet nowadays, global warming. I think that does it. Yep, we'll be getting into global warming and the ozone effect. That'll be tomorrow. So that wraps it up. And